Yes, sir. All right, here we go. So describe the amount a square has been rotated counterclockwise. So it just really just depends on your answers. If you were in L1, if you were part of L1, you should have gotten a 53.13 degree rotation. A lot easier to use this little device. Right. And if you're in L2, you should have gotten whatever 180 minus that is. What L2, what y'all get? So you got negative, but because you landed in quadrant 2, you needed to add the 180 to get the 126. Very good. So that was the actual degree of rotation. If you're in L4, no, my bad, I lied. L3, because I don't know what comes after 2. What you all get? Good. And what you got was originally 53.13, but because you're in quadrant 3, you then need to add 180 to that result to get the 233. Very good.
So how come 2 3 days?
Because they end up getting a negative 53.13. So in L1, your degree of rotation was like right here. For L2, their degree of rotation was over here, and they gave them, the calculator gave them that result, but they needed this result. And then L3, it gave us this result right here, but I needed the whole thing. So I added 180 to that as well. And then also with L4, what y'all calculate? Perfect. And this one, you would take the, because you originally got negative 53 because it gave you this result, but to calculate the full angle, I needed to add 360 to it to get that 306 degree rotation.
That's the line.
So 270, if you, that would put you somewhere over here still. And that would be, and the reason we added 180 also to this one is because we got a positive result. Had I gotten the result that went in a negative direction, then, and that only really works with cotangent, but we're not messing with cotangent right now.
So
No. All right, so that should have been all y'all's degree of rotations. Y'all's dilation was all what? 5. And we calculate that by finding the modulus. And again, to calculate all these, this was tan inverse of B divided by A. And depending on what quadrant you fell in, it's depending on what you did. So the modulus was calculated by A squared plus B squared. And if you probably didn't notice because y'all probably didn't look at the other ones once I told you what group you're in, but all of y'all had 3s and 4s, and I just changed some signs in there. So regardless, I should have ended up with 9 plus 16, regardless if it was a positive or negative, which then gave me a square root of 25, which gave me a 5. So now knowing that argument gives you the degree of rotation from what you're multiplying when you're multiplying by a binomial, and the modulus gives you the scale factor part. And then part, of course, this right here is the same results. I don't know why they asked this question again, but on part D, now I'm going, now that you know that, can you tell me what the degree of rotation is going to be and the dilation without doing all of the graphing, right? Because I'm sure all of y'all graphed y'all stuff and y'all probably got things like this. Here's your original box. And then you got a box like this. And looking at that, you probably aren't going to be able to easily tell what the degree of rotation and the scale factor is until you did this math here. So with that, how do I find the scale factor if I multiply by 2 plus I? What do I got to do? Just find the modulus, which is the square root of A squared plus B squared. So if I find this modulus here, what is my A? So 2 squared, what is my B? 1. There's always like an imaginary 1 there. 2 squared is, 1 squared is, square root, 4 plus 1 is So square root of 5 ends up being my scale factor. So this is my scale factor. After that point, we also saw that our degree of rotation just comes from our argument of theta, or our degree that we calculate. So if I calculate my argument, now granted, you might have tried to attempt to see where it falls on the unit circle, but all of those degrees aren't degrees that we have. So that would have to then be the tan inverse, actually 2 plus I. Nah, we don't got square root of 5. So that'd be tan inverse of, what's my B in this situation? 1. Do you understand that, Jacob? You were asking, how do I know what my B and A is? So if it's in complex form, A plus BI, my B is that imaginary part. Okay. And then divided by my A, which is 5. And what did you all calculate? Your A is 2. Very good. I did that on purpose. Y'all did really good on catching that. Totally kidding. I just looked at the other thing. So what's the inverse of 1/2? 26.56 or 57, whatever. All right. Do I have to? Yes, sir. Scale factor. Yes, sir. Correct. No, it's square root of 5. Yeah, the other one was square root of 25 that became 5. This one is the square root of 5. I can't simplify it, so the square root of 5 is the scale factor.
So what did that change?
So 5 is like 5, but square root of 5 is like 2 point something. It's a little bit smaller, actually. Yeah. So so when you did the part E there, your square was probably not as big as what you got the first attempt, because it's like half the size of the factor. All right. But where does my 2 plus I, what quadrant does that fall in? 1. So do I need to do anything with this degree? No. So there is my degree of rotation. Right. I'm not going to do all the work so that you can get the points there, but you would just fold it out and you would get a square that looks, again, something like this. Here's your original. That was part E, to actually test it out to see what it ends up being.
Do like
Yeah, you'd do the 4 points and you'd probably get something again like this. Not as big scaled as the first time, but still bigger scale. I'll go ahead and do it.
oh, you okay.
All right. So we're still using the same points. So A is 1. So I'm 0. You're right, 0. So that's 0 plus 0I. So I would then take 2 plus I, and I would distribute this out. Right. And when I do that, I do end up getting 0, 0, right? So that point doesn't move. And then when I do B, that's just equal to 1 plus 0I, or just 1. So I take 2 plus I times 1. And that was the very first question in your group. Why is B going to end up just equaling your original thing that you're multiplying? You're just multiplying by 1. So you should end up getting the exact same thing. And this coordinate is what? So then I go 2, 1. Here is my new B. And then C was equal to 1 plus I. So I would do 2 plus I times 1 plus I and fold it out. So I give you 2, and then 2I, and then 1I, and then I squared. What's I squared though? -1. So then 2 minus 1 is 1, and then 2I plus 1I is 3I. So what is that as a coordinate? 1, 3. So I come over here, I go 1. There's my new C prime. I'm gonna do the work over here for D. D was equal to just I. So then that would be 2 plus I times I. And you could make that 0 plus I if you wanted to, but I'm just going to just distribute this to make life a little bit easier. And that gives me 2I plus I squared. But what's I squared equal to? -1. So then I get -1 plus 2I, which is just what as a coordinate? So I go -1 up 2, and there's my D prime. And as best as I can here, I'm going to make my square. So again, you see that's not nearly as big as your first attempt because your scale factor was half of 5, basically. And then your rotation, you can see that 26%, it barely comes off the x-axis. All right, what time we got out of this class? All right, so we will do lesson 15 tomorrow when everybody is here. Any questions on that though? Okay.